Hello, my name is Logan Kroger, and I'm going to be talking about list comprehensions for my video assignment for Computer Science 372. Python list comprehensions are a way to do a for loop in one line. Here you see on the right, we have an example of a Python list comprehension broken down into its parts. To start, we've got this x variable, that's the return value. We've got this for and in purple, that's the for loop. We've got x, which is the same as the return value, but that's the variable that will be used when iterating through, and here in range 10, that's the iterator. And this quote from the Python documentation says, "A list comprehension consists of brackets containing an expression, followed by a for clause, then 0 or more for or if clauses." Here's a basic example of list comprehension, the same one that we just saw. This is me in the Python REPL, x for x in range 10, and here you see when I print out the result of the list comprehension, because of Python ranges, it's 0 through 9. Now what makes Python list comprehensions so powerful is being able to do everything that you can in a normal for loop in these list comprehensions. Any condition can be applied to return value following the iterator from our previous example after range 10, which we'll see in this slide. Here, same example in range 10, and then afterwards we will only add the return value if x mod 2 is equal to 0. Here you see with the result that it's 02468. Here's an example with strings. Here we have a list of fruits, mango, pear, pineapple, etc. Fruit for fruit in fruits if P is in the name. And here we see the result, pear, pineapple, peach, and mango and orange were left out. Now the return value, the variable defined at the beginning, has to be a variable, otherwise we see what happens here. We have that same list of fruits, we're making a new list, and we've set mango as the return value. So every time it iterates through every one of those fruits in the list, it's just returning mango. And the only useful application I thought of was maybe initializing a list of a certain size. But like I say down here, the list produced will only contain the constant given as the return value as many times as the iterator ran. But constants can be used in the return value in a sort of precondition kind of fashion. Here we have that list of fruits again, and here we see fruit if fruit equals orange, else banana. Another way of thinking about that is fruit is only fruit if it's equal to an orange, otherwise it's a banana. And here we see in the result that every time it goes through one of those fruits, if it doesn't equal orange, then it returns banana. But when it is orange, it just returns orange. Here's another example. Same way of thinking about it, fruit is only a fruit if it is not equal to a pineapple. Otherwise, if it is equal to a pineapple, it's an apple. And here we see in the return value, mango, pear, apple instead of pineapple. Here's an example with numbers. Here we see x squared for x in test, and in the return value we see that, or in the return list, we see that every number was squared, because we modified that return value every time it iterated through the original list. Can you do a precondition and a postcondition? You can, and my first thought when I learned about this was it could be pretty useful for filtering out lots of data. Here you see we have the original list of 0 to 9. X is only x if it is not equal to 2, otherwise it's equal to mango, and because Python lists can be heterogeneous, this substitution works fine, so it's 0 mango 468. And we check at the end of the list comprehension over here if x is even, and then we return it. ListComps can also be nested just like regular for loops, and they can contain conditions as well. Here's an example that I adapted from the Python documentation. We have a matrix here with 2 rows of 4 values. Now we iterate through the row in each matrix, and we iterate through each value in the row. Here it's range 4 because there's 4 values in a row. That's the outer loop, and then the inner loop is row in matrix. And we end up with a transposed matrix where there's 4 pairs of 2. So instead of having to write a nested for loop, we have that little nested list comp, and it produces the desired result. In short, Python list comprehensions are very powerful, very flexible. This class was the first time I had ever seen one or heard of them, and including this into your everyday Python programming can save a lot of lines, and they are very readable, very understandable. They can get pretty complicated with the pre and post conditions and the nesting, but it's a very fast and powerful way to create a large list of values, and can also be used for filtering pre-existing values.